Assalamualaikum warahmatullahi wabarakatuh. Hello, my student. Today we will study about linear regression. The module is by Anika Khatkova, and you know that linear regressions is very simple regressions in econometrics, very basics, but many people use it. So here today we have the linear regression overview. So the linear regression example and linear regression model, estimated regression line, single versus multiple regressions, and coefficient and marginal effect, goodness of fit or F square, and the hypothesis testing or hypothesis testing for coefficient significance. There are two. The first is t-test and for single coefficient significance, and the second is f-test, multiple coefficient significance. So there is the objective of this lecture today for linear regressions. The linear regression example. We hope that the student could apply the linear regressions and using the data. And also, we hope that the student could apply the linear regressions using data analysis tools. Okay, this is the linear regression example. Explain student grades using the number of hours studied. And the second, explain the effect of education on income. The third is explain the effect of the number of bathrooms on house prices. And the last, explain the effect of recession on stock prices. The linear regression using to explain, or interpret the correlation between the independent variable on dependent variables. And here we have two variables. The first is independent variable. Here, independent variable for the first, when you expand the student grade using the number of hours, then the grades is independent. Dependent variable, and the number of hours studied is independent variable. And then the effect of education on income. Education is independent variable, and income is dependent variable. And the effect of the number of bedrooms on house prices. The number of bedroom is independent variables, while the house prices is dependent variable. And the last, the effect of recession on stock price. Here, the recessions is independent variable, and stock price is dependent variable. Okay, let's set up the linear regressions. Regression analysis does not establish a cause and effect relationship. So this highlight this statement that the regression analysis does not establish a cause and effect relationship. Merely, they express the the correlations or relations. So there's only a relationship. And the cause and effect relationship must be determined using a theoretical model or logical reason. And here there are also the requirement that in the OLS or linear regression, that is, the dependent variable is a continuous variable. And the independent variable can take any form, continuous or discrete or indicator variables. The simple linear regression model has one independent variable. The multiple linear regression has two or more independent variables. This is the presentations of the linear regression model. Yeah, here y equal to beta 0 plus beta 1 x1 plus u in error terms. Here, you can also write by y equal to x accent beta plus u as error terms. Here, y is the independent variables, yeah, as explained, predicted or response variable. X is independent variables or control variables or regressor, and beta are unknown parameter to be estimated. So beta 0 is an intercept, while beta 1 is a slope. U is the error term or disturbance. Okay, and we'll move to the goodness of fit or R square. Here's the parameter that present the goodness of fit for estimated regression equation. It means that if R square is high, it means that the independent variable could explain the dependent variables. The coefficient determination or R square provide a measure of goodness of fit for estimated regression equations. Values of R square close to 0 indicate that perfect or fit. Perfect fit. Values close to 0 indicate poor fit. R square that is greater than 0.25 is considered good in the economic field. R square interpretations, if R square equal to 0.8, then 80% of the variation is explained by the regression and the rest is due to error. So we have a good fit. Okay, then we move to the t-test and also f-test significance of the coefficients. So here t-test is used to determine whether the relationship between y and x j is significant. While here the hypothesis is h null is beta j equal to 0 and H alternative or hypothesis alternative is Bj not equal to 0. Here the null hypothesis is that the coefficient is not significantly different than 0. And the alternative hypothesis is that the coefficient is significantly different from 0. And when we use the t-distribution, in the test statistic t, t equal to a coefficient of standard error. The critical values are from the t-distribution. The t-test is two-tailed test. Here, we reject the null hypothesis and conclude that coefficient is significantly different from 0 if the test statistic t is the critical rejection zone, while the p-value is less than 0.05. Then the goal is to find the coefficient that are significant. And then the last f-test of overall significance of all coefficients, with testing whether the relationship between y and all x variable is significant. The null hypothesis is that the coefficients are jointly significantly different from 0, and the alternative hypothesis is that coefficients are jointly significantly different from 0. Okay, then thank you very much. Let's move to the practice. Wassalamualaikum warahmatullahi wabarakatuh.